Carly, you can still hear me okay? Good morning, everybody. We'll get started in approximately 4 minutes. Good morning, everybody. My name is Shubham Gupta. I am the network sales engineer for EtherWAN, and I'll be the presenter today along with David Choyer, product manager. And our marketing team is managing the chat box in the background, and they will be sending you more contact information just in case you have questions and would like to reach out to us. So definitely check out the content in the chat box, and in the handouts, there will also be the actual presentation that we will be doing today. So it will be a resource for you if you would like to follow along in that as well. COVID-19 update. I know it's a tough situation, but I hope everyone's hanging in there, staying safe with your families. Um, it is a really good time to gear up on some knowledge. So part of EtherWAN's efforts with our Learn from Home webinars, we plan on bringing tips and tricks for you every week that will help you make really cool network deployments on with the limited resources. Also, we have inventory on most items for almost immediate delivery. Win big. So we have a Amazon gift card giveaway at the end of this webinar, where you will have a survey that will pop up right up, and you fill it in, and basically our marketing team will choose one winner for an Amazon gift card. And a shout out to Michael Lombardi from Vector Security, our last week's winner. Michael, I hope you're on this webinar with us as well. So congratulations to you. Real quick before we get started, just a breakdown on who is EtherWAN. Our company was started by NASA engineers, where in GPL they needed switches for hardened environment and indoor environment. So that's where we started, and we've been in business for approximately 20 years, more than 20 years, in fact. And we have lifetime warranty on all hardened products, US-based technical support from 6 a.m. to 6 p.m. Pacific time. A lot of fresh training material on EtherWAN Academy courses, and our marketing team will also be sending links for that in the chat box. So make sure to check that out for more detailed information on networking best practices and our products. We do our own manufacturing, so we have control over everything. We are TAA compliant, and we also have proprietary patented technology such as POL and EasyLink, and some of this technology we'll be checking out in our webinar today. Topic for today is old alarm wire. Yes, telecom wire that will network. So what we want to do is look at tips and tricks that will allow us to take old infrastructure or old copper infrastructure and turn it into modern types of networks. But before we get started with that, I also want to talk about some of the challenges. Some of the main challenges are short time and budget cuts, right? Time and money. That's what we want to. That's usually some of the main factors that prevent us in projects from going fast and implementing all types of networks. So especially in the COVID situation, where we have even more budget cuts and limited amount of time for some of the projects where you need to get some network set up, but again, not enough funding or running out of time. So some of the other challenges that we'll see is with fiber is that fiber costs too much, and for some of the installations, for example, it could cost from $1 to $6 per foot, depending on the fiber count. And for example, if you're doing a building with approximately 100 to 200 drops, that whole fiber installation project could cost anywhere from $15,000 to $30,000. Another factor is due to the COVID situation, that those fiber projects that you have planned on, they may be getting pushed to a later time, but your challenge is you need to get the network set up as soon as possible. Those are the challenges with fiber. Another challenge with Ethernet cabling is that we have a limitation of 100 meters, which is 328 feet. But some of the runs for your network, they may be longer than that. So that's another challenge that you may be facing. So the solution for that is we can try to use any sort of twisted copper pair. Now, this type of cabling is more of a older type of cabling infrastructure that some of the buildings from 80s and 90s have already installed. This type of cabling, it's already been installed. So some of the projects you have to either take it out and upgrade to fiber, or but it's some of the buildings or ITS infrastructures already have this type of cabling. So in this presentation, we'll see how we can leverage this type of cabling to build those modern infrastructures. The return on investment on this type of cabling is pretty high, because even though this type of investment is already there, we will just invest in new products that will use alongside these cables to build those modern infrastructures. And as you can see on the left, we have a spool that I just found on eBay, and it's a 24 gauge shielded cable pair. It has 2 pairs, 2,000 feet for approximately $60. So even if your building or your project doesn't have, enough funds for fiber, doesn't have enough for Ethernet cable, and not even for wireless, a spool like this can be easily set up and provide you network bandwidth for your upcoming projects. Now let's talk about the connectivity. Again, the idea is very simple. You have devices in your field, whether it's a temperature sensor, IP camera, or any sort of access controller, and you have some sort of control center, and you want to connect these two. Now, again, talking about some of the challenges that we discussed earlier, may not have enough funds for fiber installation, or your fiber projects are getting pushed back, but time is of the essence, and you want to get these projects running. So what can we do? We could definitely leverage those twisted pair old copper cabling, add some new type of technology, the Ethernet extenders, and turn this whole network into a modern running network. And we do that with a technology called Very High Bitrate Digital Subscriber Line, Vdsl version 2. It's just a way of retrofitting old type of infrastructure with modern networks. The way VDSL2 works is it takes digital transmission, so digital data, which is your bits 101011, and it's being sent in analog signaling analog. So essentially, even though you have this cable, which is running analog signaling, inside of it, it's digital transformation, again, which is why it's a modern network using old infrastructure, old copper infrastructure. Now, even though we're using this old type of cabling, there is one catch to it, and that is the bandwidth. As you can see, as the distance is getting higher in this chart, as the distance is increasing, some of our bandwidth is decreasing. But it's great because at 1.37 miles, you're still able to communicate approximately 6 Mbps as a downlink speed and uplink speed of 0.6 Mbps. Even though it's low, you have to see that you were able to leverage the old existing infrastructure. And even though your cameras or controllers, they don't require too much bandwidth, these are able to get your network up and running very quickly. And up till 10 feet here, you're running at 100 Mbps, which is still a good amount of bandwidth for your cameras. Now let's talk about the setup part of it. There's unmanaged and managed. In unmanaged, it's very simple. It's plug and play. Plug and play. You connect the wires and you're done. But the catch with unmanaged is it's kind of like driving a car with no dashboard. It's functional, it will get your system running, but will you know if you're running out of gas, how fast you're going, are your tires low on air or engine trouble? You don't really have access to that kind of information. It's just plug and play. Managed, on the other side, provides you a really fancy dashboard, as shown below here, where you could see, okay, this is my VDSL status. This is how much signal to noise ratio I'm getting. And I can even set what speed I want my network to run at. Kind of like cruise control, right? Where you can put a limit. I only want to drive my car at 50 miles per hour. So just like that, you could set, I want my VDSL link to only run at either 20 megs. I want my link to run only at 90 megs, just like that. So managed definitely gives you that access and ability so you can control your network on a more granular scale. Now we're going to start talking about the topology and the topology aspect of it. So we're just going to start from the basics again. Very simple. You want to connect your control center, your laptop, to a camera. And the way you do that is you connect your laptop to this EtherWAN device here, which is an unmanaged Ethernet extender running that VDSL2 technology. And this is a copper cable right here, just like your Ethernet cable, like a Cat5. Here, same thing. I'm connecting my camera to this unit on this end, again with a Cat5 as well. And in the middle, this is my old copper twisted pair, which I simply just plug in. It's one pair, so one end goes in this terminal here, the other end goes in this terminal here, and you just, using a Phillips screwdriver, you just secure those connections. Same thing on this end, and plug and play, and then there's LEDs to show you what speed your connection is established at. So that's the very basic setup. Now we're going to go a little bit in depth. So Vdsl is a point-to-point technology. What that means is when I make that pair connection from here to here, I cannot add another third device here and just tap into this existing connection. It's only point-to-point, so this connection here is only for communication for these devices. And again, you simply cannot tap into an existing connection. Where you can, this can be sometimes easily confused with, like, tapping into a like a power connection or something like that. This on the other hand is a data connection, so tapping into it like that will not work. So let's get creative in how we can use a simple connection like this to build different type of topologies. T connection. This picture here is very similar to the last one, where we have, a daisy chain, point-to-point connection here, point-to-point connection here. But if I have another connection that I want to tap into it, again, I can't tap into this connection, but what I can do is throw in another device here and connect this device with this device using a Cat5 or 6 Ethernet cable, right? So let me say that again. So you have this device here that supports 2 VDSL connections, this device here that also supports 2 VDSL, and same thing here, 2 VDSL. This mini device here only supports 1 VDSL connection. So the trick to doing this is, since both of them are occupied, one is occupied here, the other one's occupied here, what I can do is use an Ethernet cable and connect to this device, which again can then connect to my my copper connection here, building a T type of connection. And again, here we're just understanding the fundamental of it, but later I'm going to show you an application, an ITS application of how this fits right in. No fiber, no problem. Here's another interesting topology where we can leverage the copper pair and get really high bandwidth speeds. So in this, again, very simple topology. You have your copper pair, you put the Ethernet extenders, which are again always used in pairs, and you connect that to one switch here, and you connect that to your devices here. But what I could do is I could set up multiple pairs and aggregate these links together. So if I'm getting 100 Mbps here, 100 Mbps here, 100 Mbps here, and 100 Mbps here, again, I just aggregated those links using a protocol called LACP, which is Link Aggregation Control Protocol. And I just turned that into a 400 megabits per second link. No fiber, no problem. This is a very creative example as well that we have been using in ITS markets. And again, I'm going to show you an application in a little bit. Kill 2 birds with 1 switch. So in this example here, if you set up a ED3575 device, such as this one, which supports VDSL and it has fiber ports. So what you can do is, if your network infrastructure right now only has copper available, you can go ahead and set up your network with that copper connection. But say 5 years down the road, you get approved for funding for fiber, and you're like, okay, I want to set up the fiber in my network now, but I don't want to buy more switches or anything. So what you can do is you could take that copper out and install fiber in. Again, these type of switches, they support both VDSL connections and fiber. So even though right now you may have copper connections and in the future you may have fiber, you're only changing the medium in this setup. Your switches still stay in the same spot. So we like to call this concept of, killing two birds with one switch. You're ready for now, you have a solution for now, and you're also prepared for the future. Another creative solution we could leverage with these twisted pair cabling is power over link, which is the ability to send data and power over that same old twisted pair that we have been discussing in this presentation. This utilizes a different type of technology. These units, again, they're sold in pairs, and they're called POL units that you could use with a twisted pair, and you could use it with coax cables. And simply, it's a way of making PoE happen, which is power over Ethernet, again, with the medium that's only available at the moment, so which is copper pair, right? Very simple. I connect one end Ethernet cable to my core switch or my aggregate switch, and between these two devices, the transmitting and the receiving end, I have my copper pair. And on the other end, I just connect one of my devices, whether I want to connect a camera, which is PoE, whether I want to connect this access control unit, could also be PoE, and my wireless unit, again, PoE. This is the unit, the T unit. This is the only one that requires a power source. This R unit does not need a power source because this unit here is sending enough power to power this device and your PoE device. So again, in this one, we're able to send power and data. If you use a copper pair, you could get up to 3/4 of a mile. But if you use coax, you are able to get to 1.1 miles in this distance. So a lot of the topologies that we just discussed, it could be used in various security solutions, whether it's LOD, VIP, emergency call boxes, access controls, building automation, parking lots, or even video surveillance. A lot of the old existing infrastructure in these applications, they have installed, copper pair or coax cables in late 90s or early 2000s. So the solutions that we're discussing is a way to leverage that installed infrastructure to make the modern solutions. Now, here's another topology, very popular in security, where you have a switch at a head end, right? And you use Cat5 or Ethernet cable to connect to these these Ethernet extenders here. These Ethernet extenders connect to your different buildings or different locations using those copper pairs going to site 1, copper pair going to site 2, and copper pair going to site 3. And on this end, we want to use a switch with more Ethernet ports because we have more devices. So in this building, right now I have a wireless access point and I have a camera, but since I have these other available ports there, I can definitely install more cameras and more network devices in the future. Now, for example, if I start adding more and more devices, then what I could even do is, again, that kill two birds with one switch. So I could get rid of this fiber. I could even install fiber and go straight to my head end switch and get more bandwidth from my network that way. Now, here's a more bigger security application where I'm using, here I have my head end switch that is utilizing that POL technology, using this coax cable to power these emergency call boxes, LED lighting, or even PoE cameras. I have the coax cable here running at 100 Mbps and delivering 30 watts at my end art location. So I can connect this directly to my head-end switch here. The second example is more of an ITS example where we're using the copper pair cabling, which has been installed in early 80s, 90s, and I'm able to power these telephone emergency call boxes this way. Here I have copper cable, but then here I have fiber. So in this application, it started off with the copper, but as the new phases of the fiber project are coming out, this copper has started being replacing with the fiber. But again, the switch stays there. No need to take the switch out because it has a solution for now and for future. Here's the application for a parking lot, again, where we're using, we started off with a situation with either a copper cable or a coax cable, but then again, the network started changing to fiber, so we could start supporting bigger cameras that require higher bandwidths. Here's an oil drilling platform. Again, very similar idea. Here we're powering, putting the PLCs on our network. So we have a control center, we have a head-end switch here, only requiring with 6 ports, but then off of this head-end switch, we have these ED3541s, hardened, unmanaged Vdsl units that are able to go to the field where we have the PLCs, and then they're putting devices such as motion sensors, smoke sensors, oil sensors on the network. ITS application here where we have interconnect installed in the city already. We're able to utilize that infrastructure and build daisy chains off of it. So again, these units, they only have 2 VDSL ports. So you have one connection coming in and one connection going out in a daisy chain, one connection coming in, one connection going out. So again, earlier we talked about the T valve, right? The T, it's kind of like a T valve, T connection. So if we had a connection, a road connection coming here that we'd like to install a switch at this location, but how do we connect that to the network? Again, we just add another small unit here, the ED3541, which has one VDSL unit, and you connect that to this switch here using Ethernet cable, and then now you just opened yourself up to expanding your network in this direction here. Another ITS application is sometimes you may run into longer distances that you want to cover. So again, with these distances, we're able to get to 1.3 miles approximately with these units. But if you have a run that is longer than that, we have devices that go up to 12.4 miles. And you can even leverage like a combo system where at one location you may install this unit here that supports 12.4 miles, but in this case we're running 5 miles. Again, I connect this unit to my switch with multiple ports using an Ethernet cable right here, shown in the green. And then to this switch, I connect all my devices. In this case, I have controllers and cameras connected to this switch here with multiple ports. And then these two are used in a pair to cover the distance of 5 miles, connecting to this network here. So it could also be used in a combo system like that. In this case here, I only have 3/4 of a mile. So I didn't need to leverage these units. I just directly connected my VDSL unit here to here. So we have the ability to cover approximately 12.4 miles. Main takeaways. We're able to turn existing copper infrastructure to modern networks with limited resources. We do have the ability to cover all the way up to 12.4 miles. And the concept of killing 2 birds with 1 stone, where we have a solution for now, utilizing the copper infrastructure. And then we're also ready for the future with the fiber cabling. POL had the ability to send power and data over the twisted pair as well. So you're able to power your devices such as cameras, wireless access units, all over PoE. So you don't have to install power at the network site. Here's a summary of the products that we talked about in this presentation. We have the managed switch, which is the one we heavily saw in the ITS examples. Here we have the unmanaged device that has only one VDSL port. This one had two. This one here is another Ethernet extender that has one VDSL port. This is better suited for indoor environments. This is better suited for your hardened environments. And then again, you had these two units here that are able to support your VDSL connections up to 12.4 miles. Here's a summary for the power devices, the POL. This device here is for your copper connection, and then this device here is for your coax connection. And now we will go ahead into the QA section. So please, if you have any questions, send them in the chat box and we will go through them. So I'm going to go ahead and read some of the questions that are in the chat and I will start answering them. One of the questions I see is, can I use something besides Cat5? Yes. So any type of Ethernet cable, the Cat5 was merely an example. So, Cat6, you could use any type of, as long as it's an Ethernet connection. But for your VDSL, you're able to use any twisted pair. So if you want to use even Cat5 for your VDSL links, you can, because the Cat5 technically has four twisted pairs, right? Great question, Paul. I have a question from Joseph. Does VDSL see any better performance if greater distance or increased bandwidth if using a larger gauge copper twisted pair? Yes, great question, Joseph. So we noticed that, well, first of all, we're able to use up to 24/8 gauge connection. But if you use something like a 18 gauge or a 20 gauge, we did notice a relatively better connection because the cable is thicker and it's able to provide a little bit more reliable connection. Not only that, it's a little bit increased bandwidth, and the reliability of the connection is a little bit better. Like better if you were to ping one connection to the other end, much more better data communication in the thicker bandwidth. So lower gauge, definitely preferred. But we do have a limitation. We can't really put 16. We're able to support from 16 gauge to 24 gauge. Are there bandwidth limitations based on number of VDSL devices? I have a question. Give me 1 second. I have a question from Stefan. What if these long-run single-pair cables from VDSL have splices? If they have splices and they're going through different, terminations and different splices, that is going to affect the bandwidth a little bit. So you may experience a little bit loss in the bandwidth. So our recommendation is definitely try to have as much um, smooth, like direct connections as possible. As long as the VDSL link impedance is 100 ohms, though, Stephen, we should be, that's our ideal goal, 100 ohms, and we'll be able to get establish smooth communication as possible with 100 ohms. But yes, going through different splices may affect that. So we recommend if you have like a VDSL tester, you could even test those connections. And then, if you're able to get those 100 ohm impedance, then we'll be able to establish that connection very well. Do you have any distance or bandwidth slide similar to slide 15 for various gauges? Joseph, we can definitely send that in the chat. We do have something like that available. I will note down your email and contact information, and we could actually share that with the rest of the attendees as well. I have a question from Dub. Are there bandwidth limitations based on number of VDSL devices? The only bandwidth limitation that we have, Dub, is like based on the distance, right? So I'd like to refer back to this chart. So as you could see here, approximately half a mile, we're able to get like 50 Mbps sort of communication, uplink and downlink. But if you use managed type of device, right, that will, because that has like a CPU built in it, it would probably require a little bit more bandwidth to access the console of that device versus unmanaged, which really doesn't have a dashboard, so it's not really on the network itself. It's more of just a pass-through device. I have a question, how much power can the POL devices support? And that's approximately, we're able to give approximately 30 watts up to the end device, but mileage may vary based on the distance that you're trying to establish. I have a couple more questions coming in. This is great, you guys. Great questions. I would like to share a story for an install that I have with a couple of these VDSL units, because we have a lot in ITS applications. We have a lot in security applications. So I'd like to take this moment to share that with you. One example for ITS, let me go ahead and draw. Give me 1 second. So for the ITS, it's a very common application that we started with, the concept that we said to kill two birds with one stone. So in this particular city, we had a lot of twisted pair cabling installed, right? So this is intersection 1, this is intersection 2, this is intersection 3, intersection 4, right? So you have a switch here, switch here, switch here, switch here, and four pairs of twisted pair cabling. So it was really interesting in this city because the killing the two birds and one stone concept, we actually realized that while we were working on this project, because earlier the city was planning on removing all the twisted pair here, 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 and they were going to install the fiber. But just last minute, one of the fiber projects got canceled. So, what we decided to do was add the VDSL units instead. and make these connections VDSL connections. So we were able to establish, 100 Mbps, 100 Mbps of links. But what we realized was at certain intersections, City wanted to, install different devices. It was not like every intersection had same number of devices. Some intersections had more, some intersections had less. So what we noticed was like for example, this intersection, I may have two cameras, one controller. This particular just had one controller. This one had one controller. And then this one had, for some reason, this one had multiple controllers, I believe for testing. So I could say 2 controllers, 2 cameras, 2 sensor devices. So idea being that this switch here had definitely more equipment than the other ones. So what we ended up doing was we left 100 Mbps connection for this connection. We left 100 Mbps here. And then since we noticed that the bandwidth in this daisy chain started allocating more and more, here we use that LACP, the link aggregation. So we have 100 here, we have 100 here, we have 100 here, we have 100 here. So we established all these 4 connections. So here we turned it into a 400 megabits per second connection. And then that way we continued on to the TMC, which is the traffic management center. And here we did the same thing where we were able to aggregate the connections here. So here I have 100 Mbps, and I'll use this in a different color so it stands out. I have 100 Mbps here between these 2 connections. I have 100 Mbps between these 2 connections. And then here I have 400 megabits because I have more devices that I started adding up. So the bandwidth here is bigger than the network here. So it really just depends on what the application is and how many devices your customer or you're planning on implementing. But wherever you're adding more devices and it needs more bandwidth, it's just the idea of, hey, does my network have enough bandwidth to support all those devices? I'll take a couple more questions. Looks like that's pretty much it. We do have more information, detailed information on how much wattage these certain devices can support at certain distances. And I believe we had a question where somebody was asking, do you have a table for different gauges and how does that improve the bandwidth? So we'll definitely share that information with you guys as well. Feel free to ask us for any more other questions for any specific data sheets. We're more than happy to send that to you. And here's more contact information for inside sales and Eastern Regional Manager. So I'll leave it at this slide. And thank you so much. Thank you, everybody, for contacting us and enjoying this webinar. And we'll definitely come out with more tips and tricks next week. So stay tuned.